Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face Trending List, published on June 25th, 2025. This paper, published just 2 days ago, introduces a model that matches a much larger one's performance while cutting internet searches by over 30%. The paper is titled MMSearch-R1, Incentivizing LMMs to Search, and it offers some really practical insights on building smarter, more efficient AI assistants. The authors use reinforcement learning to teach a model to be more resourceful, deciding for itself when it truly needs to look something up. Also, the authors shared their implementation on GitHub. You'll find the complete end-to-end reinforcement learning framework there, including the code for their multimodal search tools for both images and text. They've also included scripts and instructions to train and evaluate the models yourself, which is always great to see. Alright, so this first figure really breaks down how the model works in practice. It shows 2 examples of visual question answering. In one, the model sees a picture of Peking opera and identifies it correctly using only its internal knowledge. But in the other, when asked for a specific date about a lunar rover, it recognizes it needs more information and performs a search. The chart below compares this MMSearch-R1 model against models using retrieval augmented generation, a technique where the AI automatically searches for every query. The results show the new model is more accurate while searching far less. Building on that, this next figure illustrates the training process itself. It's a reinforcement learning framework, which is a method of teaching an AI by rewarding good decisions. The core algorithm here is called Group Relative Policy Optimization, or GRPO. This algorithm uses a reward model to score the main model's actions, giving it a high score for accuracy, but also applying a penalty for unnecessary searching. This incentive structure teaches the model to first check its own knowledge before deciding to use its image or text search tools, which is exactly the efficient behavior we want. Now, to teach the model this complex behavior, you need very specific training data. This is where the author's custom dataset comes in, which they call Factual Visual Question Answering, or FVQA. This diagram shows how they built it, starting with visual concepts, searching the web for related images, and then using GPT-4o to automatically generate question and answer pairs. The crucial step is how they process this data, creating a search balance set that mixes examples requiring a search with those that don't. This balance is what trains the model to be discerning. Okay, so this table really shows the payoff. It compares performance across several benchmarks, including that factual visual question answering dataset. The 2 columns to watch are accuracy, which is judged by another LLM, and search ratio, which is simply the percentage of times the model decides to search. You can see models that never search are not very accurate. Then, models using a retrieval augmented generation workflow search every time, boosting accuracy, but they're inefficient. The star here is MMSearch-R1, achieving high accuracy while searching far less, demonstrating that on-demand approach really works. And this figure really digs into the how. It compares the reinforcement learning approach to a more standard method called supervised fine-tuning, or SFT, which just trains the model on examples. The bar chart on the left shows that reinforcement learning gives a much bigger accuracy boost across the board, even using less data. Then, the training graphs on the right are very telling. Without a search penalty, the model learns to search constantly. But with the penalty and the balanced data set, it finds that sweet spot, searching much less but more effectively. So to wrap things up, the key takeaway is that you can teach a large multimodal model to be much smarter about when it searches for information. Using a training method called reinforcement learning, which rewards good decisions and penalizes unnecessary searching, the MMSearch-R1 model learns to trust its own knowledge first. This makes it more accurate than standard methods and also far more efficient, cutting search calls by over 30%. It's a big step towards more practical AI agents. That's all for this week's AI Research Roundup. Thanks for tuning in.